That scared me.
Yeah. All right. Question 1. Which of the one of the following equations is not balanced? So the question is asking to what the balance equation. So I'll write the answer here. Question 1.
D.
The only one that didn't was not balanced was the question D. As you can see, the nitrogen number is balanced, but not the oxygen. So the D is the only answer. All right. Easy question. Fresh start. Question 2. Which one of the following quantities would have the greatest mass? Greatest mass. So how to find the greatest mass? So for that, we need to find the molar masses of everything. Okay, and if you find the molar mass of that, the first one, the butane would be the 58.1. So A would be 58.1. B would be the 1-propyl amine would be 59.1. C would be the 58.1 again. And D is the 60.1. So out of these four, as the D, which is the ethanoic acid, has the greatest molar mass, with the same number of the moles, which means that it will be the heaviest. So the answer is D. The trick for that is think about the number of the carbons and the hydrogens, and it will match. You can compare the number of the carbon and hydrogens, and as you can imagine, the oxygens are generally heavier than the nitrogens from out among these. So having more oxygen means it could be the heaviest. John, can you see the board?
Not at all.
Okay. I will just stop sharing. How about now?
It's a little blurry, but I can see it a little.
Okay. Yeah. This is the best I can do with the
This is
webcam.
okay. Yeah.
Good. Okay. If you can see the writing on the board, it will be great because I'm writing the answer here. Good.
Yeah.
3. Which one of the following contains the largest amount of hydrogen chloride, HCl? Again, we have a liters and mole and liters that. So you just need to find whether using this. Brandon, do you remember how to find the number of moles? How to find the N? N can be found. Okay, we can find the CV, or sometimes N can be also found in mass of molar mass. Very good. Or N can also be found in gas. PV equals nRT using that. The PV on RT. Okay. Or if you know the standard room temperature, which is some case of the B, these, maybe not. Yeah, some. Yes, all of them.
Oh.
But don't use it. I mean, this is common sense now. This is common sense. Yeah, this is common sense. It's like your quadratic equation. Exactly. Minus b plus minus root b and root b squared minus 4ac. All right. This either at the STP, standard temperature, and let's go for SLC because we are SLC. There's as the volume is equals to N times the Vm, N is also equals to Vn on Vm, which is V volume divided by 24.79. Do you remember the value? It's given on your formula sheets, by the way, but you gotta use this. So using these equations here, we are looking for the largest amount, which means just find the number of moles. The answer would be A. A would be the greatest out of among the everything here. Everyone good? So nothing fancy here. I mean, we just try to use the some basic common sense, the chemistry common sense. Question 4. When 8.8 grams of the oxide of nitrogen are decomposed at 3.2 grams of oxygen are formed, the empirical formula of the oxide is most likely to be, okay? So to do that, they have to think about the number of the nitrogen. So mass of the nitrogen can be found from 8.8, which is the total number of the nitrogen oxide, minus that 3.2. Does it make sense? Oxide of the nitrogen means it's a combination of nitrogen and oxygen. And we're given the mass of the oxygen, means that by deducting that value from there, we gotta get the mass of the nitrogen. From here, we can find the number of moles, which is, so that will be 5.6 grams. So 5.6 divided by 14, then you should get the 0.4 moles. So what about the number of the oxygen? As we're given the number of, the mass of oxygen given at 3.2, 3.2 divided by 16, that's giving you 0.2. What is the ratio? 1, 1, 2, 2. Therefore, it'll be N, 2, O. It's the final answer. So question 4 answer is A. Okay, everyone good? 5. An important reaction in the production of sulfuric acid is conversion of the sulfur dioxide and sulfur trioxide. The mass of sulfur trioxide produced when 60 grams of sulfur dioxide is reacted with the 10 gram oxygen. Okay. So we need to find the mass of sulfur trioxide produced when 60 grams sulfur dioxide is reacted with 10 grams of oxygen. So I know this takes a little while, but I want you to go through some of the finding number of moles from here. So number of the mole of the SO2 given here, SO2, say sulfur dioxide, can be found by m over molar mass, that is 60, divided by molar mass of the sulfur dioxide. So that will be 64. I found that for you. And then you should get 0.938 mole. It's too easy. I mean, I'll get it up to here. Also, find the number of mole of the oxygen is what? Same, m over mm, and we're given that mass is 10 and divided by 16. So the number of mole for the oxygen should be, O2. So that means that 32. Didn't see the 2. 10 divided by 32, so you should get 0.313. So looking up the reaction ratio, this is 2 to 1. Well, you know, times 2 of that would only be what? Jump in. Times 2 of that would be?
0.6.
Yeah, so it would be, do we have too much of the SO2 or too much of the O2?
SO2.
We have too much of that. It means this is a limiting reactant. You don't need to write the working out, by the way, because it's multiple choice. So by in your head, hey, this is a limiting reactant, means that all of these will be reacted. Make sense? And the question is asking you what? How much of the mass of the sulfur trioxide? So as the molar ratio of the O2 to the SO3 is 1 to 2, therefore N SO3 would be 0.313 times 2, that's 0.626 mole. Are we done? No. Time from here, find the number of mass of the SO3, 0.626. Mass M equals to N times the molar mass, 0.626 times 80, which is the molar mass of the SO3. Then you should get 50. So the answer is B. So that question takes a little while, more than 1 minute probably. But if you had lots of practice with defining number of moles, if you're good at like in finding which is the limiting reactant, which you will get in your half yearly for sure, you'll be all right. Okay. But for the type of question 5, I'll probably just recheck the question 5 when I have a spare time. Or if you're not too sure, go for C. I know you got it wrong, but you know it's only one more.
And I got it all wrong.
Good job.
That means I was like 26% chance.
Yes, 25.1% chance. Slightly higher than others. Slightly higher.
Every time I did not question, I was like, oh,
Yeah.
see.
A and B, A and D. Let's see how many C's will we get after this. We can determine the percentage here. But A and D has the lowest percentage so far. I mean, like collecting all. But there's a statistic again. 6. All right. 4 compounds of carbon, hydrogen, and oxygen have the molecular formula CH4O, C2H4O2, C3H8O3, and C4H8O3. When placed in the order of the increasing the percentage of the oxygen in the order. So what do we do for this? We found that number of the percentage. So we can find, first step, find the total molar mass, okay, and divide, or find the percentage of the oxygen using the molecular mass. Okay, so for example, for the first one, CH4O, total molar mass of this. It's good to know you can memorize the molar mass of the carbon, hydrogen, oxygen, because it will be used in the module 7 again. That's 12 plus 4 plus 16, so that's what? 12 plus 16, 32. So oxygen takes about what? As oxygen is a 16, it takes about 50%. This is how you find the percentage value. Make sense? If you do so, you will find that question 6 answers C. So show me if you guessed that C, you got it right.
I didn't guess.
You
I did
didn't?
my working out.
Yep. And did you get it right?
Yeah, I got it right, but
Good.
I just did what's closest to my working out.
This is what you need to do. Find the total molar mass, and that divided by the molar mass of the oxygen contents. So the percentage will be 50% for the first one, 53.3 and 52.2 and 46.2. So this is the reason why C is the answer. All right, 7. 32 grams of compound of carbon and hydrogen contains 2.18 moles of carbon. The molecular formula of the compound is most likely to be, all right, again, we have given the mass and find the molecular formula. All right, to do so, start off with the carbon and hydrogen and contain 2.18. So, we don't know. We can construct the formula. So mass of carbon, let's start from here. The mass of the carbon from the given mole, which is 2.18, is 2.18 times molar mass, which is 12 for the carbon. That is 26.16 gram. Everyone good up to here? Okay. So we got the mass of carbon within that 32 grams. So mass of unknown hydrogen, therefore 32 minus 26.16. That would be 5.84. That means that from the mass of the hydrogen, we can find the number of mole of the hydrogen as n equals to m of molar mass again. So 5.84 divided by 1.08, approximately that's 5.84. Or 6, you can say. So therefore, it'll be under molar ratio as number of moles, the carbon, and carbon is 2.18. And oxygen, hydrogen is 5.84. So what you need to do is divide that with this one value. So make it this one, and when you divide that, you will get to what? You would actually get to 1 to 2.67, approximately. It's not a complete 2 or 3, which means that we need to make it in the whole number. So you will end up to 3 and 8. So the molecular formula would be C3 and H and 8, which is the what question? C. Again, is the answer. It could be the A, but 2 to 5, yeah, approximately, because try to get the whole number, yeah. I'm just thinking like that. 2.67 times 3. That's a bizarre number though. No, 8 is the most correct number. Because times that is 8.01. Okay, bizarre, I know. But times 2 of that is 5.1 something, which is slightly bigger than this value. Yeah, tricky. All right, 8. What volume of water? What volume of the water must be added to 20 mils of the 9 moles of hydrochloric acid to produce a concentration of 1.5 mole per liter? Okay, to find that, we need to use this. C1V1 equals to C2V2, which is used for the concentration or dilution solution. So we have C1, we have 20 mils, the 9.9 for 9 per mole, and the 20 mils. So convert that into, you do not need to convert the units for as is the ratio value. Doesn't really matter. I just use 9 times 20 equals to 1.5 times V2. So finding V2, you would get the answer of A, which is 100 mils. Oh, sorry, you would get the V2 is 120 mils, by the way. But the question is asking you how much water is need to be added on the top of the 20 mils the volume of the water that needs to be added is 100 mils then. So that answer is B, A, not the B. Good. 9. Under suitable condition, oxygen and the carbon monoxide will react according to the equation. That's 2CO plus O2 goes to CO2. A mixture of the carbon monoxide and oxygen had a volume of 1 liter at 60 degrees Celsius and 101.3 kilopascals. Good. The mixture is allowed to react until one of the reactant is completely consumed. The final volume of this temperature and pressure was 800 mils. Okay, the most likely composition of the mixture after reaction. Okay, who understood the question?
9.
Question 9. Jomin?
No.
Okay. John?
No.
Okay. Let's go for the step by step. So we have some condition given, 2CO, I just copied that down. 2CO carbon monoxide reacting with oxygen to become just 2CO2. Alright, so we have mixture of carbon monoxide and oxygen had a volume 1 liter. So mix of CO2 and O2. The volume of this is given as 1.0 liter at the 60 degrees Celsius and 101.3 kilopascal. They are allowed to react to one of the reactants is completely consumed. So we don't know which will be consumed, which will be left over. So it doesn't really matter yet. The final volume at this temperature at the pressure was 800 mils. So what happened here is after that, the final volume after the reaction, so final volume is decreased to 800 mil. The most likely composition of the mixture, okay. But you get the point here. Before the reaction happened, we used to have 1 liter. So we let the reaction happen, so reaction between carbon monoxide and oxygen, and in the final result we only get 800 mils. Where did the 200 mils gone then? They are evaporated. No, not evaporated. They're left off. I mean, they'll be. So what determines the volume if we have a same temperature, same pressure? What would determine from the gas factors? What determines the volume if we have a fixed, constant pressure and constant temperature? It'll be moles. It'll be number of moles. So we're gonna find. You have to notice that this is a question about number of moles too, and this is the reason why they're looking for this. So for that, so we have to calculate the amount of CO and O2 to produce the CO2. Okay, let's think about each cases here. When we're having the 500 mils and 300 mils, yeah, there's something wrong with the questions again. Okay, so they try to make 800 mils all together, so a 2-to-1 reaction, CO and CO2. All right, I tell you what. Hey guys, if we have 500 mils of CO2 initially, Jomin,
Yes.
if we consume all of the CO2,
Yes.
okay, if we consume all of the CO2, what would be the volume of the CO2 required? Or let's think about the condition here. CO2 is something that produced, isn't it? So CO2 is your product. Yep. And O2 and the CO is the reactant. According to the gas laws, because we are dealing with the same number of moles here, what we have to determine is the product volume will be determined by the volume of your reactants. Everyone does it? Everyone makes it? Yeah, okay, I get at this point up to here. Which means that, hey, if I have 100 mils of the oxygen, okay, and if I have 200 mils of the CO, according to the reaction ratio 2:1, there will be 200 mils of the CO2 produced using the molar mass the reaction ratio, molar ratio. Jomi, does it make sense to you? Going through again, if I have 100 mils of that, the amount required to react fully is 200 mils of the CO according to the reaction ratio, and that will produce 200 mils. It's nothing fancy, okay? Means for the A, when we have 500 mils of CO2 and 300 mils of O2, does it make sense? Does it follow the molar ratio? Does it follow molar ratio? I mean, if I have 300 mils of O2, there must be 600 of the CO2, not the 500 mils. So A cannot be the answer. What about B? We have 400 mils of CO carbon monoxide, and we have 400 mils CO2. Now you can see that CO and CO2 have the same molar ratio 2:2, which is a 1:1 reaction. So answer is B. Kind of tricky because they're giving you lots of the informations. It seems like we need to use it, but if you attempt to use the ideal guess law anytime in here, you're trapped.
So is that just a trick question?
This is just a trick question.
Why would they bait us into using it? But when it's so much more simple?
Information, I know. Yeah, this is what the chemistry do. Yeah, this is what we do. Giving you a bunch of like a half of a page of the information, and the only information you need is the last bit. You only needed to know that the last bit here too.
Yeah, they give us so much like extra information.
Yeah.
And I think, oh, we need to use that.
Yeah. So yeah, that's a trick in the chemistry, unlike the physics. All right, 10. Solution of the ammonia NH3 contains 3.7 times 10 to the minus 4 moles of ammonia dissolved in the 100 ml of solution. What is the concentration in gram per liter? So how to find the grams? Again, the mass of the ammonia, as we have moles, M of NH3 is equals to N times the molar mass. That's 3.70 times 10 to the minus 4 moles times molar mass of ammonia, that is 17. Then you'll get 6.29 times 10 to the power minus 3 grams. Now what's the volume we have? We have 100 mils. So 100 mils is equals to 0.1 liter. Therefore, the concentration in unit of the gram per liter will be 6.29 times 10 to the minus 3 gram per 0.1 liter, which will make 6.29 times 10 to the minus 2. Therefore, answer is B. It's kind of even.
So easy to memorize.
Don't worry. I'm not gonna ask you to do the multiple choice. You're not only gonna do the short answers. I'm not that stupid.
I'm so confident.
I won't give you any free mark, Jomin. Yeah. All right, 11. Well, if you want to do, you can do it. You can try it. But there's no point. All right, 250 mils of aqueous solution contains 0.9 mole of ethanol. If the density of the solution is 0.932 gram per milliliter, then the concentration expressed as a percentage composition is, okay, going through that. Have to find the mass of ethanol first, M of the ethanol. Ethanol is, yeah, oh, okay. Could be happen. C2H5OH is the ethanol. Yeah. It's yeah, it is required. Ethanol, because it will be very common in year 11 at the in module 3 and module 4, and even for year 12. So if ethanol has that, the mass of that can be found by 0.9. Yeah, it could be an easy question then. 46.1, which is the molar mass of ethanol. So they would get 41.49 gram for the ethanol one. All right, from here, as we need to find what? The percentage composition. If the density is giving us that, means the mass of the solution. Chomin,
Yes.
If we have a 250 mils of this solution, and if the solution has the density of this, what would be the mass of the solution then? Have to find the mass of solution. So if the mass is given as this, it means mass can be found from the volume times the density. And to find that, the volume is given as 250. So, and make sure you follow the unit, 250 times the density, which is 0.932. Okay, then you'll get the mass of the solution will be 233 grams. The question asks you to find the percentage means that percentage of this means as we have 41.49 for the ethanol and divided by 233, then you would get the and times the 100 to make a percentage. And so it would be 17.8. So the that C is the right answer.
Can I take a photo?
12. What is which one of the following solution has the lowest concentration of the chloride ions? So again, we have some situation here. So 100 ml of solution contain 0.05 moles potassium chloride. Okay, I would like you to give it a go for this question 12 later, but the answer is A. So what you can do, just simply define N from the given conditions there, and you need to compare them. So find the lowest concentration from them. But remember that the question is asking you the chloride ion only. And I'll give you the second one. Calcium chloride, and many of you made a mistake. Calcium chloride is not CaCl, it will be CaCl2. Means that depends on the number of the chloride ions you have attached to the cation, the concentration can be doubled or sometimes tripled. Okay? All right, 13. 80 mils of the ammonia are mixed with the 80 mils of the oxygen, and the cause to react according to the following equation is this. After the reaction, the temperature and the pressure are returned to the same values as at the beginning of the experiment. The total gas volume will be, so what we have to find, so question 13 now. What we have to find first is 80 mils of the NH3, okay. Tricky. Sky. If the volume of the NH3 is given as 80 mils, yeah, what would be volume of the oxygen gas required to react? If we have 80 mils for that, what would be the volume of oxygen required?
40.
That would be 80 from 80 times 3 divided by 4. So that will be 60 milliliter of O2 required. I'm just using the reaction ratio here again. That's our amount required in here. But in fact, what we have is we have 80 mils of oxygen. Okay, so after that, what we get is, have to think about it. So all of the NH3 will react. So it means that after the reaction, there will be 20 mils of O2 left over first. So we have excess 20 mils of the oxygen first. Okay, but the answer is not a 20. We have to consider about these here. Chongmin, if we consume 80 mils of the ammonia, what would be the volume of N2 as a product? N2, following to the reaction ratio.
40?
It would be 40 mil. Very good. What about the H2O? It's 4 to 6.
120.
120. Very good. So adding up all the 120, 40, and the 20 mil, which is the leftover oxygen, you would get 180. So answer is D. Highlight this question. I think one of the years, some of the schools, we had that question in the short answer form, not in the multiple choice. And that wasn't easy. This is not an easy question. I'm not saying this is an easy question to do. Because you have to think about, there's a trick that, hey, the 20 mils oxygen is left over. And many people forget about adding this in the final value. But Brandon, what you have to remember here is gas volume would also follow the reaction ratio first. Okay, it means that there could be some limiting reactant too, and we can use that to find out the volume. All right, any questions up to here? All right, let's go for 13 and 14. When a sample of the hydrocarbon is completely burnt in air, 1.76 gram of carbon dioxide and 0.9 gram of water are formed. The empirical formula of this hydrocarbon is, okay, let's go for that. So sample hydrocarbon, we have carbon dioxide and water. Okay, it will be now common sense that when the hydrocarbon combusted with the oxygen gas, in the complete combustion there will be CO2 gas and H2O. I will ask you to memorize that once we start module 3 too, but it's good to know, just good to memorize. This is the common sense. And probably you will learn that in year 10. You should. Oh, don't tell me you don't. Okay, you did. You did the combustion. You did the oxygen, reaction with the oxygen. This is part of the year 10 stage 5 science syllabus. Okay? Maybe your school teacher asks you, oh, like ask you not to memorize it, or like they didn't really mention it. But I'll ask my student to memorize that.
I don't think we did experiments.
It's not an experiment. It's just chemical reactions, like neutralization. You should know what the neutralization, what type of the reaction they are. Same for the combustion of the hydrocarbons or fuels. Okay, so for that we now have the number of N CO2. So start find the number of the CO2. Carbon dioxide we have 1.76, so M over molar mass for the formula 1.76 divided by given the molar mass of this, which is 44, and you'll get 0.04 mole. Okay, and H2O will be 0.9 divided by molar mass 18. Then you should have the 0.05. Jungmin, looking at that, these two CO2 and H2O.
Is it A?
Yeah, what can you tell me about the reaction ratio? Or let's think about the hydrocarbons, CO2 and H2O. Carbons from the hydrocarbons, so hydrocarbon could be like a CX and HY. Okay, Brendan, if this is completely combusted, reacted, from here, from these two products, which will determine number of the carbons on your hydrocarbons? The carbon dioxide. So if we have certain number of moles in the carbon dioxide, would it be the same number of mole for the hydrocarbons one? Yes. So that N carbon on the hydrocarbon is therefore equals to 0.04 mole. Make sense up to here? Okay. Same procedure. What about the hydrogen, Brendan?
Hydrogen
can be determined by water. So as we have 0.05 mole of water, what will be the NH?
0.1.
Yeah, 0.1 mole. What is the ratio between these two? Ratio is
2 to 5.
2 to 5, 2 to 5, 2 to 5, 2 to 5. Yep. 4 to 10, 2 to 5. Therefore, empirical formula must be C2 and H5. Highlight that question too. It's not an easy question. That's something you can surely give it a go. Give me 10 more minutes. I give you a break.
So I don't camp.
Mm.
It's so exhausting.
Physically, I know.
Yeah, how did the tennis game go?
I lost.
John was bragging.
John, they're asking you about asking me about how the tennis game. Oh, shut up.
Was it 6-3?
No, 6-0, 6-3 or something.
6-0.
Yeah. Why did you ask me that?
We already talked about
I
it.
do
We're gonna
remember.
rematch next time.
Huh? What was that?
We're gonna rematch next term.
Yeah, we are rematching next term, but no.
Same place, same location.
No different.
Yeah, maybe.
I'll
I think
make sure to go there.
you told me you're gonna be there last week.
Yeah, but I forgot to go. I want gym instead.
Okay, go to gym. Go to gym next time too.
Down my calendar.
Okay.
The time as well.
Oh, whatever. Okay. Yeah, I had a fun, but yeah. Oh, we had some rallies after, but yeah, I had a fun from that, not from game. It was like, yeah, game wasn't fun at all. Oh, shut up, John. Oh, I think you can play tomorrow. You're totally fine now.
I'm gonna play tomorrow. I think I'm gonna be.
I think you're playing with the David guy or the young fella too.
Yeah.
Yeah, he was pretty alright. Okay, 15. Just 6 more questions to go for multiple choice, and we're gonna have a break. 40 mils oxygen is reacted with 32 mils carbon monoxide to produce carbon dioxide gas, as in the equation below. If all gas volumes are measured at the same temperature and pressure, what would be the final composition of the gases when the reaction is complete? Okay, again, question is asking about the ratio values. We have 40 mils. We have 40 mils of that too. So what we have to concern here is the P and T are the constant. That means that number of gas would be directly proportional to the volume of the gas according to Avogadro's law. Okay? I'm not adding anything fancy here. So 40 mils of oxygen is reacted with 30 mils carbon monoxide. Okay? The volume of the oxygen given as 40 mils, and carbon monoxide CO2 is known as 32.0 milliliter. Pressure, what would be the final composition of the gases when the reaction is complete? Okay, so thinking about the reaction ratio here again, CO2 and CO and O2, carbon monoxide, sorry, it's not a CO2, just CO simply. So thinking the reaction ratio for the CO2 to CO2 is known as 1 to 2. Does it make sense? So it is a very similar question to the question 13, by the way. So as this goes through reaction, means that O2 it has only the CO2 will be the reaction. So for the 40 mils of O2, there will be the 80 mils required. Means that the COO is the limiting reactant. So excess O2 will be. Started with the CO, CO. That if we consume all of CO, the amount of the O2 required will be 16. So 40 minus 16, that's a 24 milliliter for the O2. I'm just using the reaction ratio, which is 1 to 2 between oxygen and carbon monoxide, CO. Okay, so using that, as we have this and this much and this much of the CO and O2, then can you tell, hey, we have too much of the O2 compared to CO according to reaction ratio, means that this will be left over.
Yep.
And I just found that how much of the O2 will be left over by using the reaction ratio from here. If we have 32 mils of the CO, using the reaction ratio, that will be 16 O2 required. Does it make sense to you? Yeah? means that 40 is what we have, but 16 is only going to be used. The excess will be 40 minus 16, that will be 24 mils. All right. Looking for the product side, we have a CO2. CO2 means that it has the same reaction ratio of this CO. So if all of the 32 mils are consumed, Sky, what would be the volume of the CO2 produced then? If we consume all of the CO? 32. So using that, it would be the 24 mils of oxygen and 32 of the CO2. The answer is B. If you're confused about this type of question, I would strongly recommend you to try it again. Okay, John. Jongmin, this is very similar to the finding limiting reactant, but instead of using number of moles, we're just simply using volumes. Make sense? Good. All right, 16. Which of the graph below represent Boyle's law? Boyle's VBP. So it's about the volume and pressure. Okay, this is a type of question we can get in the school exam too. But what we have to think about here is we have the inverse of the P. Okay, now if we have the volume versus pressure, it would be the inversely proportional. It would be. So what you have in the x-axis is not the P, it's 1 over P, inverse of the P, means that it will be C. There will be direct proportional. This is what I mean by like you can get this kind of question in the school exam. They're not going to give you, I mean, some schools, I think Pacific Hills, giving you the questions like this.
Yeah, probably.
Yeah, probably. Your schools will not.
Is it because my school's so advanced?
Yeah. I think like they can't be bothered to make the question twisted. And most likely no one's get it. Yeah. So they just go for basics. They just go for fundamentals first, and then it's not good. But HSC later on too.
Yeah, does HSC have trick questions?
Yeah. About like there's a half and half. There are some trick questions.
Why is every question basically a trick question?
Well, it's not a trick. They're not all.
Question is basically-
No, not all of them are trick. Some.
Most.
Yeah, about.
They're like bait you into. It's like they want you to get a bad mark.
No. I mean, the purpose of giving a trick question is they really want you to think about the question, not simply memorizing and answer the question. And that's the trend of all the subjects these days. So they're not going to give you a question like something you can memorize and practice and just write. No. 17. A balloon has a volume of 1.5 liter at 25 degrees Celsius and 101.3 kilopascals. What will be the new volume if the pressure decreases to 95.3 kilopascal? Okay. So this is what? Using the ideal gas law, so PV equals to nRT. And the N is constant value, R is constant value, temperature is now constant too. So we don't need to worry about this, but we have to just concern about V. So V was certain value, B1 was nRT. It's more of a math question. That N times R times which is the constant value, temperature which is the constant value too. So I'll make a T. Or simply, let's think about this. We have the reaction between Sky. What's the relation between volume and the pressure?
Indirectly proportional.
They're indirectly proportional. They're inversely proportional. It means that VP is equals to K, as V is indirectly proportional to P. Yep,
Yeah.
we use this according to Boyle's law again. So as Vp is equals to K, so simply using, we have 1.5 liter and 101.3 kilopascal. Use that. 1.5 times 101.3 is the constant value, which is equivalent to the new volume V2 times the new pressure 95.3. Therefore, K is equals to 1.5 times 101.3 divided by 95.3. The volume, sorry, V2. I'm just using the Boyle's law again, and you should have 17 answer C, then 1.59 liter. Tell me, there's no twist here. There's no trick or twist. Good. And this is C too. You could have guessed the C.
Yeah, I probably guessed it. There's no working out anyway.
All right, 18. The volume of gas syringe is 500 mils and the gas pressure is 99.5 kilopascals. What will be the new pressure if the volume is decreased to 225 milliliter and the temperature remains a constant? So again, something about the gas solids. What we have here is the change in the volume with the new pressure if the volume is so volume and the pressure again. So volume and pressure is indirectly proportional. So Vp is equals to constant. I'm going to use the Boyle's law again. So we're given that 500 mils for new volumes. So 500 times 99.5 is equals to 125 times the new pressure P. So P would be that divided by that. So for that, answer would be A, which is 398 kilopascal. A sample of the 0.35 mole of the fluorine has a volume of 5.9 liter. At constant temperature and the pressure, what will be the volume occupied by 2.3 mole of the fluorine? Okay. So we have a constant temperature and pressure, and the question is asking you about. Tell me, what is the question asking you about? Which factors of the gases?
Mole and
Yep. And what's the relation between mole and the volume? So asking about the volume. What's the relation between these two? According to Avogadro's law? Directly proportional. Very good. So it means N over V is constant too. Make sense? So we can simply use what we have. So N, which is 0.35 on 5.9, should be equals to 2.3 new mole on the new volume V2. Then V2, you find from this equation that would be 2.3 sorry, times that 5.9 divided by 0.35. Yep, then you would get 39 liter, which is D. Nothing fancy.
The next one.
Yeah. All right, next one. Yes. Experiment. Oh, come on, definitely. For the coming exam on Tuesday, you will definitely get some experimental questions.
Wait, what exam on Tuesday?
Him.
Oh.
Come on, big boy.
You have to come back on Tuesday again.
No.
I'm not the exam.
No, I can't be bothered to mark your work on Tuesday too. So don't come back on Tuesday. Coming back on Wednesday.
You have a school assessment on Tuesday.
Yeah, they got half yearly.
Good luck.
All right, solutions of the potassium permanganate solution can range in color from pink to purple. Dilute solution appears pink while more concentrated solutions are dark purple. So crystals of potassium permanganate were added to 4 test tubes containing varying amount of distilled water as shown below. So you have to understand that we have a different volumes. Well, it's kind of described in the picture too. We have a different mass of the potassium permanganate. Guys, don't get afraid of these kind of complicated formula, complicated chemicals. Potassium permanganate will be very common from now on. Yeah, it is. I told you, this is the oxidizing reagent that you need to memorize sometimes. But now, don't worry about it. Even though you have something very complicated, use your periodic table to find the molar mass. It will be related to that. 20. Once all of the crystals have dissolved in each of test tube, the test tube containing the solution that is palest pink. Brandon, what does it mean by the palest pink in terms of the concentration? Exactly. The lowest concentration. The question is simply asking to find the concentration of the 1, 2, 3, 4. Then you would see which was the lowest. And you find the concentration of them, the answer would be C. The test tube 3 would be the lowest. And as we can see from there, pretty much from the grams and the volume of the distilled water too. 21, the concentration in gram per liter potassium permanganate solution in test tube 2 is, okay, if you find the test tube 2 and you convert that into gram per liter, 21, the answer would be A.
Yes.
It's not a complicated question again. Yep?
Yeah.
All right, let's have a short break.
Spent an hour working which was that's not
For some of the questions, Brandon, did we go through this question together? Yes, for some of the questions we tried it in class. Not some, many, about half of this paper.
Great.
We actually did the half of the questions together before your exam, and I put the exactly same question in the exam too. So, yeah,
the percentage of like iron sulfate.
Yeah.
I know that one. Did you get that right?
I think we did that like last week, the week before, yeah. We did that question and did some other questions before too. So, I mean, you should be able to find the working out in the previous the working out pages. So we did that question 22 basically, and we discussed that, hey, the questions are designed to find the number of moles, so asking to find the Avogadro's number. So let's go quickly on the questions like this. A, calculate the number of the moles of tungsten in the block. So to find that number of the moles and tungsten, W can be found by amount we have, 154.4 grams divided by molar mass of tungsten. This is 183.85. So really,
0.9, what am I doing?
yeah, you put the 0.9. I don't know what you're doing. So 0.83 98 mole. What did John do? He put the 9 instead of 85. Yeah, I was like, why'd you line it up? No.
What am I doing? I lost both the marks because of that.
Yeah, exactly. It's the one you want mark, by the way. B, calculate the volume of the one atom tungsten using volume. When you okay, guys, when you need to write the units of the volumes, you need to find the volumes in the milliliter. Do not leave your answer in the centimeter cubed. Okay, that is one thing. This is very important. The units must be following the unit given here. As a volume unit given in milliliter in your question means that you need to follow that unit. Okay, or if you just follow that in a liter, it's fine. So when you put it that, we know that atomic radius is 137 picometer. So I think somebody asked me before that. Picometer is 137 times 10 to the power of -8. Oh, sorry, -6. Minus micro, nano, pico, p. It's given here. -10. Sorry. Okay, so using that, substitute that into a formula that is V equals to V 4 and 3 and pi r cubed. You should have the volume is equals to 1.077 times 10 to the power of the -23 milliliter. Okay, say calculate the number of the tungsten atoms in the block, assuming that there is no space. Okay, the total volume. This is giving you total volume, 1.077 times 10 to the -23. Make sense up to here? Means that as we know the total volume, and also we know what? The volume of the tungsten. Sorry, yeah, that's the total volume. So the number of atoms can be found from total volume divided by volume of one atom. The total volume is given as what? 8 milliliter in your given question. It's given in your question. We just found then the volume of the one atom. So 8 divided by that value, you should have the 7.4 times 10 to the power 23 atoms for the final answer. All right, D. Calculate the Avogadro's constant number based on the result. So how do I find the Avogadro's constant based on that? So this is not a question about the ideal Avogadro's number. You need to use the Avogadro. So think about what I mean by the Avogadro number. It means that for 1 mole, we have some Avogadro's number of the Na, I should write, the Na number of the atoms. Does it make sense?
And for question B,
Yep.
did we not have to use that? The
This
volume equals 4/3.
we do. So put that into the this is your radius. Put that in your formula. You get that.
Oh.
Mm.
I just wrote 137.
No.
And then I got it in picometer.
Yep.
And then I changed it.
Yep. Did you put that into the volume formula?
Milliliter. Yeah.
4 and 3 on pi r cubed.
I got 0.001077 milliliter.
Mm. But that's minus 23.
Yeah, so.
Check your calculator again.
But then you gave me a mark for it.
Did I?
Yes. Let's go! I should have kept my mouth shut. Wait, let me write this down.
Well, I can change it. Bring that. Okay,
I'll just
I'm
take
more
it.
than welcome to change it. I corrected. Okay, sorry, it was my bad. I made a mistake. So thanks for your honesty. Okay, I can change that for you. No, leave it. Okay, you can get extra mark. Don't worry, doesn't matter.
I deserve it.
Doesn't make a difference. Doesn't make a. I mean, doesn't make a difference. Like you still be below 50.
Come on, man.
If that makes you happy, I'm happy with that too. Okay. Anyways, do you guys get the concept? 1 mole means that this number of this much of the Avogadro's number of the atoms. We gotta use this. We gotta use this. So as we have 0.8398 moles given, and a number of atoms given this here, which means based on our data, based on our investigation, this mole would have this many atoms. Okay, that means we can find that for 1 mole, we can divide these two. So 7.4 times 10 to the power 23 atoms divided by amount of moles we have, which is 0.8398. Then you to get, yes, you should get 8.8 times 10 to the power 23 atoms, or the molecules, or particles.
But it doesn't say divided into 6 things.
What was your specific value?
11 6 things. I was being accurate.
Even that is not accurate. I mean, for the sig
Wait, where did you
for the
get
sig
11
figs,
sig figs?
nowhere. Calculator. He just copied that what the value he had in calculator. No. Try to follow whatever sig fig given in your given samples too. There are 2 or 3, no, but not the 11.
Yeah.
Not 11. I would take it right if you just go for like the 4 or 5, even 5 sig figs, because we have 5 sig figs there. But try to follow the smallest sig fig values, except the 1. So this is why I followed it on 2 sig figs. All right, question E. Yeah, we discussed that before too. How do these values compare with the expected value of Avogadro's constant? So what you need to do, you need to show there's some expectation value, which is what? 6.02 times 10 to the power 23, which is our non-Avogadro's number. Compared to that value, this value is about what? About 25 or 40, 30% greater. So the calculated value we found is actually about 25 to 30% greater. You need to find the value, okay? Which means, and why is that? Because we didn't really count that in the spherical shape. There could be some empty spaces. All right, so there will be some volumes. There's some mistakes in the volumes. Therefore, we are having the greater number of the particles than the actual Avogadro's number. Make sense? Okay. That's the answer for E. By the way, there's only 1 mark question. All right, question 20.
What's the answer for E?
Jomi, you're nodding. You're like, oh, yeah, now you're nodding. You as if you understood everything. You're listening to me. You're like, so what was the answer again at the end? Okay. The answer is because we didn't really count the spaces between the atoms to the atoms. The actual value, the Avogadro's value we calculated will be greater than about 25 to 30% greater than the actual ideal Avogadro's number.
Oh. I wrote that and I got 0.
Did you?
Yeah.
Did you write that? Okay. Well, I give you extra marks. Okay, let's compensate. Okay.
Wait,
Same
sir,
thing. Yeah.
Can you write B again? I can't see it.
B. Did you convert the picometer is the 137 times 10 to the power minus 10?
Let me see. Probably not. I did not.
No.
Oh, wait.
Then what do you need to do after you convert that? Put it into the formula, the volume formula, which is 413 pi r's cubed.
Isn't it 4 over 3 pi times 137 times 10 to the power of negative 10?
Yes, and the cube.
Oh, everything cubed.
Yes, everything cube.
Oops.
Yeah, that's common mistake too. All right, 23. Calculate the percentage composition of the iron sulfate. Those who didn't get the full mark for this question, you seriously have something wrong with you. Iron. Okay. Brendan, iron sulfate, when they're asking you to find the percentage compositions, they're asking about individual iron, sulfur, and oxygen. So you need to find the percentage for the iron. So the easiest way to doing this question, there are two methods doing this question. I explained that before. The one method is you assume that there's 100 grams and find the number of moles, hence you can find the composition, the percentage. The second method is you simply use their molar mass. This is probably the simplest way. So when you find the molar mass of the iron 3 sulfate, so start with the iron 3 sulfate. Oh my, keeping, okay. That is Fe2 and SO4, SO4, 3. So molar mass of this, finding all the molar mass, you should have the 399.88 for the molar mass. Okay, so percentage of the iron, Fe, can be found from the molar mass. Just think about how many ions we have in that. We have 2. So 2 times iron, that is 101.11. So that making 111.7 divided by 399.88 times 100%. Then you should have that as 27.93%.
I wrote iron nitrate.
Nitrate?
Yeah, I read that.
Oh.
Nitrate?
So I did
Nitrate?
And I did
Oh.
Fe to SO4.
Wait, sir, I lost 2 marks for this because I didn't write percent.
Yeah, that's right. That's right. Well, that's what you get if you don't write any units.
That
No,
important
I
to
will
write.
show you. I got so much
Like,
worse than that.
Okay. Then I know the answer. Yes, it is.
Okay.
Really important. Really important.
Okay.
I wrote 2. I wrote everything so accurately as well.
Yeah. And you didn't write any single percentage in your answer.
Oh, that's 1.
I could just give you 0 for that.
No, the word here. That's not fair.
There we go. You got a 1 mark for that. 1 mark for that. John, admit it. You need to write the unit percentage every single time you're dealing with the question. And how many marks did you lose because of the amount of units?
A lot.
Yeah, about 8 to 10. That's like what, 10%?
You
More than
lie?
10%.
More than
You didn't
10.
deserve a mark.
Hmm?
But then you still gave me a mark.
Yeah, working out, as he said.
Thank you.
Yeah,
That's so nice.
thank you. So unit is very important. So oxygen, okay, the things about oxygen is we have 4 oxygen attached to the surface, so there'll be 12. So 12 times 16 is 192 in the total of number mass, molar mass of oxygen, divided by 399.88 times 100, then you should get the 48.01%. This is how you get accurately and efficiently.
Does that say 98.88?
No, 48 point, which one?
Sulfur.
So sulfur is 24.05, oxygen is 48.01.
No. The what that over that times 100.
Oh, 96.18. I'll try to use this board so you can see it clearly. All right, next one, 24. A balloon containing the chlorine gas CO2 at 223 atmosphere pressure and 50 degrees Celsius has a volume of 6.55 liter. Calculate the mass of chlorine gas in the balloon. All right, the things I ask you to write every single time you're dealing with questions like this. Okay, guys, I really want you to write down the given information and use the conversion method. Okay, so if showing that we have pressure, that's question 24. All right. The pressure is given as 1.23 atmosphere, and how do I convert that into standard unit, which is kilopascal? Yeah. Start with that. So it will help you to when you're writing the finalizing your answer. And what about what we have? So you don't need to write the R here. We have the temperature is 50 degrees Celsius. Convert that into our given unit of the Kelvin. So 50, the 200, as that to 273, so 323 Kelvin. Once you get that, now time to bring it up to PV equals to nRT, which is ideal gas law, to find N is equals to PV on RT. I think somebody wrote it in the wrong way, but doesn't matter.
That was me.
Yeah, that was you. Okay.
RT over PV. 'Cause I'm an idiot.
Don't make the mistake next time. We are given the 6.55 for the volume divided by 8.314 for the gas constant times the 323. Easy questions. And then the mole should be 0.304 mole. From here, find the mass of the chlorine. Now we have Cl2, by the way. So what you have to count in here is not just single chlorine. We have to 10 times 2 of the chloride. So it would be 0.304 times 2 of this, which is approximately 70.9. Then you should get 21.6 gram. Very common type of question you can get in random. What you have to remember about gas law is write it down, the given information, convert that. Okay, we did that many times. Okay, put it into the formula and makes your job really easy. I mean, I'm not using any integration and differentiation here. It's got to be really straightforward question in terms of the calculating your values. Value can be complicated because like it looks really big or small. Okay, but don't get afraid. You have a calculator with you. Okay, just you're not gonna do that with your head. I mean, this is not a chemistry Olympiad. In Chem Olympiad, you're not allowed to use calculator, by the way.
Really?
Well, what's Chem Olympiad?
How did they say they do it in the end?
They're doing that.
Oh,
It's Olympiad. Olympiad.
but still.
It's like an Olympic. So
Crazy.
yeah, it's like they are competing with the how much like chemistry and with their understanding of the chemistry. But their questions not gonna be like this. They're pretty straightforward, and it's more about the comprehensions rather than the calculation. All right. In the presence of the sunlight, this amount of chlorine is bubbled through the 650 mils of the 650 mils of the water, and the following reaction occurs. We have 2CO2, 2H2O goes 4Cl, 4HCl, and O2. So B. What volume of oxygen gas will be evolved at 25 degrees Celsius and the pressure of the 101.3 kilopascal? This is a pretty easy question once we know the chlorine. So we have this. The chlorine we have NCl2. We found that that's 0.304 mole from the previous question A. What you need to write every single time is, and I've been saying this for many weeks, for 100 times, no kidding, I've been saying this for 100 times, as the reaction ratio
Oh,
of the CO2 to O2 is what? 2 to 1. Yeah? The NO2 must be the half of the CO2. Go like this. Then what do you get? This is what? Half of that, 0.1 or 152 mole. Okay, so what you just need to find from here is the volume of O2 is therefore, as we have 25 degrees Celsius and pressure of 101.3. That is, you can use the ideal, I think you should use ideal gas law for this one because it's not it's a 1 atmosphere, not the 100 kilopascals. So for that, V is equals to, using PV equals to nRT, nRT on the P, substituting all the relevant value, and that's 0.5152, 8.314, times the temperature 25, that's a 298, divided by the pressure, which is the given as 101.3. Okay, and you should get 3.72 liter for your final answer. C. After the reaction, what will be the concentration of HCl in mole per liter in the solution? Sky, we are given that the volume is 650 mils. You do not need to find a new volume here. You didn't read the question. See? All right. Let's find the number of the HCl first. Okay, NHCl. So from that, let's think about the question. We have given the 100 mils first. After the reaction, probably the 650 water and 655 that. Okay, are we given that here?
that's more than that.
Does that say 28?
It doesn't say here. Okay, did we find the concentration? Well, no. We're doing C. NHCl. Oh no, sorry. Yes, John.
Does that say?
Hello.
Oh,
Does that say 28? 0.152 times 8.
298.
Right.
Okay. Oh, sorry. NHCl. First of all, as we have number mole of, so the question C is asking you about mole per liter in the solution. Okay, we're still doing this. Oh, just the total concentration. Sorry, I misread that. So first of all, using the reaction ratio, the reaction from the CO2 to HCl is NHCl must be 2 of the NCl2 as the reaction ratio of HCl2. Cl2 is 1 to 2 or 2 to 1. Therefore, NHCl must be 2 times that, 2 times 0.304, that's 0.608 mole. Now we are given how many moles in here? How many the concentration? So we have given the 650 mils of water. So Sky, in here, we only had water for the liquid. Means that this is the only volume for the liquid for the concentration. And means concentration of HCl is therefore 0.608 divided by, in the liter form, 0.1 liter. So you should have 605. 650. Okay, then you should have 0.935 mole per liter. Okay, D, after the reaction, what will be the concentration of the HCl in the solution as percentage mass per volume? I mass in 100 ml solution. So simply convert that into what? The unit of the percentage mass per volume. Okay, so how do we convert that? So N, you're going to use a different color. NHCl in 100 mils using that concentration, as we are given concentration, can be just times the 0.1. That would be 0.0935 mole. From here, we can find the mass of the HCl by using N equals 2, M equals the molar mass. That's N times the 0.0935 times that to 36.46. By the way, the working out and writing on my board is all required. It is a sample answer, which means that this is the minimum. And if you're missing any of the sentence, any of the lines in here, then it means you're losing your mark. So that would be 3.41 gram. Therefore, the concentration of the HCl in the percentage value is 3.41% in mass per volume. This is what you need to write in the final sentence. Okay, unit conversion. Guys, I didn't give you the ppm yet. And I warned you, you can get a ppm or ppb sometimes if they try to make a question tricky. You alright, Jongmin?
Yes.
Okay, let's do 25.
For number of moles in HCl in 100 milliliters.
Yep.
Are you sure it's that?
Yep.
Shouldn't.
Because we times 100 mils means 0.1 liter.
Yeah, but in the.
That times 0.1.
But that's in 0.65 liters.
I mean, that's the concentration.
Am I tripping?
Why is it percentage?
Oh wait, yeah, you're right.
Mhm.
My bad.
Why is it 3.1? 3.41%.
What's the other thing?
M over V.
Oh,
Sorry, what was it again?
why is it 3.41%?
Because in 100 mils of water, 100 ml solution, we have this much of the gram.
Yeah. So is it
That's 3.41 gram per 100 milliliter.
oh, is it over milliliter?
Yeah, 1 milliliter. Yeah, that's how we get the percentage value. Make sense?
Yeah.
Good. All right, question 25. 0.1377 gram of nitrogen N2 is placed in a flask and exert the pressure of the 1.03 atmosphere. When 0.2038 grams of gas X is placed in the same flask at the same temperature, it exerts a pressure of 0.97 atmosphere. Good. Calculate the molar mass of gas X. Looks complicated, but think about what we have. Since we have a same constant, volume and T are the constant, this is talking about the relation between P and N. And what we know about the P and N, they are also directly proportional. Simply increasing the number of people in the carriage would increase the pressure. Okay, which means that P1 on P2 must be equal to N1 on N2, or other way around. Doesn't really matter. Yes.
You know the symbol you use for directly proportional?
Yeah. And
What's the symbol you use for indirectly proportional?
if that's something in that proportional, V and T. We're using inverse. This is
Oh.
okay. So using that, we can use can find the number of moles first. So N2. This is placed, and gas X is placed in the same flask. Okay. So number of mole of the N2 is given as from the given mass 0.1377 divided by the molar mass of the N2 28.02. Then you should have the 0.0049 0.14. We take that as an N1. And the pressure was given as, at this time, the pressure was given as 1.03. Yep. This is one condition we have. So we got the P1 and N1. Let's time to find the N2. As we know P2. And as we can have the P2, it's given as 0.97 atmosphere again. Then P1, 0.13 divided by 0.97 must be equals to N1, 0.004914 on N2, which is the number mole of the X. Therefore, Nx2 or Nx is now can be found as this divided by that. You should have the 44 point. The number mole 0.004628 mole by solving for the N2. That is same as the Nx. Yep. Are we done? No, we need to find what? Molar mass. How to find the molar mass? We have given the mass, the molar mass of the X as N equals to M over molar mass. It will be M over N. That mass is given as 0.2038 divided by 0.004628. Yep, then you should have 44.04. What is the unit of the molar mass, guys? Gram per mole. This is required to. B, suggest a possible formula for the gas. So as we know, for that, the possible is X should be using the molar mass. It could be either CO2. It'll also be the CH propane C3H8. There are various. As long as they are matching the molar mass value, yep, you get the correct answer. So there are some ranges for this answer. 26, 1.25 gram of compound of carbon, hydrogen, and oxygen contains 0.763 grams of carbon and 0.148 gram of hydrogen. A, calculate the empirical formula of the compound. So from here, how to get the empirical formula is find the number of moles. I think everyone did pretty good with finding number of moles up to here. So when you find the number of moles, N carbon, and hydrogen, and oxygen. So I recommend you to making a column or making a table sometimes, and doing the same procedure. You get the number of carbon is 0.0635, and that's 0.147. The last you should get 0.0212. Now, my tip, to find the empirical formula, as you need to find the whole number, I recommend you to divide this number with the smallest number you have. So out of 3, the number of oxygen is the smallest, which is 0.0212. So what you need to do is just divide everything with the 0.0212. So when you divide that, then the ratio of the carbon to H2 oxygen, when you divide them, you'll get 32721. When you divide this value with 0.0212. This is a tip. This is what you need to show in your working out too. Don't just simply say, hey, according to this value, the empirical formula must be this. No, I want to say that too. This is why there's a 3 marker. Finding number of mole is 1. Divide the smallest value is 1. And give it the exact empirical formula, that's 1. Alright, B. If the molar mass of compound is 118 gram per mole, then, as we know, from the C3H7O, the molar mass of that is given as 59 gram per mole. Okay, so if the molar mass of the unknown compound is given as 118 gram per mole, which means what? That's double. Therefore, it's the molecular formula would be C6H14O2. Make sure you show some working out. Don't just simply write down the answer, because 2 marker means you need to write down some working out. Showing that, hey, this is twice. As you can see, this is twice. Times 2. Okay? (27) Determine the relative formula mass. Formula mass of the mineral malachite. Okay, so relative formula mass of the malachite.
That's molar mass, right?
Yeah, just simply molar mass. And finding that, there's a carbon numbers, and then you should get 221.1 unit gram per mole. That makes sense. I mean, this matter. B, what is the percentage composition of the copper? So copper, we have that there are 2 out of this, so you should have 57.5 or 4%, 4 something, 48 something, 48, 47, 47, 48, yeah. So in 365 should be 57.5%. C, I mean, I don't know what that's a 3 marker. What mass of the copper could be obtained from 500 kilos? So if the percentage is 57.5, I don't know why. Okay, that's simply 500 times 57.5 divided by 100. This will give you amount of the copper. That's 287. Yeah, I don't really know why that's a 3 marker. That's wrong. It should be 1. But you're lucky if you got a 3 out of 3. It's extra mark. Boost up your percentage. 28. The element silicon is produced by heating the silica to approximately 2000 degrees Celsius with carbon. So in one experiment, 800 kilogram silica is heated with the 250 kg of the carbon. So I know this is the formula is not given. So many of you wrote down silicon O2 solid combined with the oxygen or carbon, sorry, solid to produce the silicon solid and CO2 gas. So balance that. They are a little bit being balanced. And from here, what you have to do is find the number of moles of the silicon O2. That's given 800 kilo. Make sure you convert the 800 kilo to the gram. That divided by 60.09. Then you should have 1.33 times 10 to the power 4 mole. Number of mole of this carbon, we have a 250, same procedure basically. 250 times 1000 divided by 12.01. You should have that as 2.08 times 10 to the power 4 mole. Alright, as the molar ratio is 1 to 1, and we can determine that which is more. We have more of this carbon than silicon, so carbon is the silica is the limiting reactant. So following the so excess, this is excess. Okay, and then number of the remaining would be 2.08 times 10 to the power 4 minus that 1.33 times 10 to the power 4. Brandon, what'd you get for that one?
I'm not sure if I got this right or wrong.
I think you got it right for that. Hang on.
Is that 3 out of 3? Because I got 90.1.
Yeah, I think it's about that. 7,500 mole.
Oh, wait, yeah.
Yeah, mole, up to mole. And then from there, as we have number of moles, we can find the mass of carbon. That's N times the molar mass. That's 7,500 times 12.01. So you should get 9.0 1 times 10 to the power 2. No, not 2, 4. Sky, did you get that one? Good. Yep, calculation. And the unit should be gram, by the way, not the kg. You can convert it into kg if you'd like to, but don't need to. B, calculate the mass of silicon formed in this experiment. Chongmin, if this is our limiting reactant, silica is our limiting reactant, what would be number of the silicon, number more of silicon then?
The same.
Same, which is 1.33 times 10 to the power 4 as the reaction ratio of silica to silicon is 1 to 1. And from here we can find the mass of the silicon. That's N times the molar mass. 1.33 times 10 to the power 4 times silicon has molar mass of, I forgot, silicon has molar mass of 28.09, and Sky, what'd you get?
373 kilograms.
373 kg for the final answer. Uh-oh, I mean, it's not just you. Majority of people, they left the blank from question 29. Indeed, this is A mark. Okay, let me just quickly grab some water and... Alright, have a little stretch. Let me just grab some water too. Did John ask you to take a photo and send it to him?
With this not so smart animation. Yeah. I just sent him a photo to give him a heads up of how to do
And they're okay. It's not really hard question. It looks complicated because of the chemical equations here.
Was 28 an easy question?
Considerably, yeah.
Yeah. Also.
I mean, it's like the very basic type of questions because you are given, right? You need to write down from the chemical equation, find the limiting reactant and limiting reagent, hence determine that number of moles in products and grams. 29 is considerably little. No, it's not hard. It looks hard because of the permanganate, which is potassium permanganate, KMnO4, and probably you've never seen that in your life ever. And that's the reason why it only seems harder. But I'll show you. Okay. All right, let's get started. The equation for the reaction between potassium permanganate, sulfuric acid, and the hydrogen peroxide is given below, which is this. A. Calculate the volume of the oxygen at 20 degrees Celsius at a pressure of 101.3 kilopascal, molar volume of 24.05 liter per mole. Okay, how like that? That means that's a given condition. Molar volume is, if you have 1 mole of the oxygen, there will be 24.05 liter. So like something in STP or SLC, but in this case, they're giving you this to use it. They're released when 25 mils of the 0.0200 mole liter of the potassium permanganate solution is reacted with excess of other two reagents. Guys, it just looks complicated because we have many reactants and many products. And that's it. And it's giving you, it's giving you that we have excess of this and this from the question. Which means you do not need to think about this at all. What we have to concern is we just need to find the we need to find the oxygen. Let's find the number of mole of the oxygen, NO2. How do I find that? Using what? Permanganate. Okay. What is the molar ratio of the oxygen and permanganate? Is 2 to 5. 2 to 5. Which means that NO2 must be 5/2 of N permanganate, potassium permanganate. As the reaction ratio of O22 potassium permanganate is 5:2. And that's it. I mean, we are given this. So from the given moles here, 25 mils of the N potassium permanganate, we can actually find that too. From the given concentration, N equals to CV, concentration 0.0200 times 25 mils in liter, 25 divided by 1,000. Everyone following this? Okay. And substitute that into that, therefore NO2, I'm going to put it in the whole things, and 5/2 times 0.0200 times 25 on 1,000. You should have that 0.00125 mole for the number of oxygen. Everyone good up to here? Okay. Now questions are clearly giving you that, hey, if you have 1 mole of the oxygen, the volume would be 24.05, means that the volume is N times the molar volume, Vm. We're given that 0.00125 for the number of moles, times that 2, the amount of the molar volume, 24.05. Don't ever use your ideal gas law here because it's given. Don't waste your time. So you should have the 0.0301 liter, which is 30.1 milliliter in total answer. Final answer. All right. B. Calculate the volume of the 0.020 mole per potassium permanganate solution must be used to produce 0.1 gram of oxygen. Okay. Assuming that there is an excess of the other reactants. So again, we have excess of the others. You don't need to worry about anything else. We just need to care about the potassium permanganate to produce the 1 gram, 0.1 gram oxygen. So start with what we have. Mass of the O2 is given as 0.100 gram. That means that number of the O2 can be found from the mass, m over molar mass. That's 0.100 divided by 32. As you do so, you should find that as 0.003125. Everyone good? Easy up to here? So, using the reaction ratio, we learned that NO2 is a 5/2 of the potassium permanganate. Chongmin, then what would be N potassium permanganate relating to the O2?
Two or five.
Yep, 2:5, and same reason as the reaction ratio is this. Focus. Okay, as we're given that, therefore, NKMO4 is, you just need to substitute that value here. That's it. Then you get what? 0.00125 mole. But this is amount of required. So question's asking you the volume. Sky, what was the concentration of the potassium permanganate?
0.02.
Yep, so potassium permanganate concentration is given as 0.0200 mole per liter. How do I find the volume from here? The volume is, yeah, as NC equals to N over V. V is equals to N over C.
Yeah.
That is 0.00125 divided by 0.0200. Following this now? Yep. Therefore, you should get 0.0625 liter. That's about the 62.5 milliliter. It looks complicated, I know, but am I introducing any new contents here? It's all the same. It's all the same. Like, no, I'm just simply using the number moles formulas again. All right, C. This is a little harder than the previous one too. Okay, Brandon, can you read me that question, please? C.
If 40 milliliters of 0.02
Molar.
molar potassium permanganate
Yep.
solution, 20 milliliters of 0.1 molar
hydrogen peroxide
Mhm.
solution and 20 milliliters of 1.0 molar
Mm-hmm.
sulfuric acid are mixed together.
Mm-hmm.
What volume of oxygen at 20 degrees Celsius and the pressure of 101.3 kPa would be released?
Okay, guys, from the given conditions here, can you guys find me number of moles of each first? You can do this by yourself now. Can you find me the number of moles each? Sky, can you find the number of moles of each? You're given concentration. You're also given the volumes. That means you can find the number of moles easily. So find that for me.
Does molar mean
Moles per liter. The big M means that moles per liter. Okay, Scott, what did you get for the number mole of the potassium permanganate? 0.8? Are you sure it's 0.8? Did you convert the milliliter to a liter?
Yeah.
You didn't. So you should have 8.00 times 10 to the minus 4 mole. That's the first one. and you should have it's approximately 20.0 times 10 to the power. I'm gonna make it match the minus 4 altogether. Okay, so it will be easy to compare, and it will be 2,200 sorry times 10 to the minus 4 mole. So as we have unified uniform 10 to the minus 4 powers here, it's good to compare them as we need to use the reaction ratio to determine which will be your the limiting reactant. Okay, so based on that, we have 200 of the sulfuric acid. Means, oh man, this is a lot. So we can say, hey, this is excess. So H2SO4 is an excess for sure. So exclude that. Now, considering the potassium permanganate, which is 8 times 10 to the minus 4, hydrogen peroxide 20 times 10 to the minus 4. Reaction ratio is 2 to 5. Now, which is the limiting reactant? So considering this is 8 and 2 to 5 means, okay, if we consume all of this, we need to use 5 on 2 of the amount.
Are they both the limiting?
No, one of them will be, because we have excess of this. Means that we don't, we'll compare it to this one, these two will be limiting reactants, but we are finding which will be the most, the dragging the reaction the most. Okay, so molar ratio of the, so as the molar ratio of the potassium permanganate to H2O2 is given as 2 to 5.
They both are 4 point. Oh wait. They would both be 4.0.
It'll be like, and it means that there is no limiting reactant. Okay, that's fancy.
Yeah.
Oh well, they have exactly matched. Means that they'll all of the KMnO4 and H2O2 are consumed. As the reaction ratio is 2 to 5, but this is what? 2 to 5, there will be 2 to 5 reaction. 8 to 20 is 2 to 5. So I think they're the questions are kind of designed in that way. Means that we are consuming all of the potassium permanganate and all of the peroxide. Now, questions asking you to find what? It's asking you to find what volume of the oxygen then produced. Thinking about the oxygen, NO2, using the potassium permanganate or or the hydrogen peroxide, they have an equal ratio, 5 to 5. So it is equals to NH2O2. I mean, I'm using the equation, the balance equation we had previously.
Oh.
NO2 in that is same as the reaction ratio of O22 H2O2 is 5 to 5, which is 1 to 1. Therefore, NO2 should be O2. In that situation, would it be same as the 20.0 times 10 to the minus 4 mole. If you got it up to here, now we are given what? Some condition, 20 degrees Celsius and 101.3 kilopascals. Questions asking you to find the volume. And what you can use, we can use the value here. This is a simple trick. At 20 degrees Celsius, 101.3 kilopascal is 20.50 for the molar volume. So V is equals to N times Vm again. That's 20.0 times 10 to the minus 4 times that 24.05. Okay, then you'd get 0.0481 liter or 48.1 milliliter for your final answer. Little tricky. Get a 1 mark for up to here. Okay, at least you could get a mark by the number of moles. This is what I recommend to you all. Start with the finding number of moles. If you're not too sure what to do, start with the finding number of moles. It will guide you where to go next. Okay, all right, next one. It has been found that radioactive element radium emits alpha particle, helium nuclei. The number of the particles emitted can be counted with a Geiger counter. Each alpha particle is converted into helium atoms by gaining electrons from the surrounding. Certain quantity of the radium emits 3.2 times 10 to the power 17 alpha particles in 1 day. At the end of 10 days, the total volume of the helium gas produced at 20 degrees Celsius and 101.3 kilopascal pressure is 0.135 milliliter. By the way, guys, alpha particle means the helium nucleus. Yep. So let's start from here. Number of the alpha particles per day was 3.2 times 10 to the power 17 alpha particles. Sky. Then, if that emits for 10 days, what would be the total alpha particle number? Yep. 17 times 10. That's 3.2 times 10 to the power 18. That's the total number of the alpha particles. Yep. That means that then number of the helium from the given situation here, we are given 20 degrees Celsius, 101.3 kilopascals here, which means we can use that in the PV equals to nRT. From PV equals to nRT again, then N is equals to PV on RT. The pressure is given as 101.3. Volume is given as 0.135 milliliter. Convert that into the liter by times 10 to the minus 3 divided by R 8.314 times the temperature 20 degrees Celsius, that is 293. The number of the moles helium would be 5.61 times 10 to the power of minus 6 moles. So they want to know, like from the given alpha particle, which is 3.2 times 10 to the power 18, how many of the will be number of alpha particles in 1 mole. As we're given that, this is kind of tricky. So the way you can find the number of alpha particle in 1 mole is given from the given number 3.2, the total number of the alpha particle divided by the number of the helium. That was 3.2 times 10 to the power 18 divided by 5.61 times 10 to the minus 6. Then you should have 5.7 times 10 to the power of 23. It's not really straightforward and easy questions because like using alpha particle and gamma. Okay, 31. I think we had that question in your chapter exercise. Okay. Did we have that in the one of the chapter exercise questions? Explain the development of the ideal gas laws. Did you have that question before or the first time?
Wait, is it the one that just tells you to list all of them?
Okay, 6 marks. How are you gonna get 6 out of 6? So first of all, you have to state all the states. All.
But it says ideal gas laws.
Yes, we're gonna start from here. So all gas laws, because we have to talk about the development of the gas laws, development of the ideal gas laws. So we have a Boyle's, Charles, Gay-Lussac, and Avogadro's. Okay, the Boyle's law is a BVP. The volume and pressure are inversely proportional. So Vp is known as K. In the Chassis law, we know that T and V, temperature and volume, is V on T is K2, constant value, as they are directly proportional. What about Gay-Lussac? The PT, P on T, also the constant. Yep. What about this? Avogadro's, the number of moles and the volumes are directly proportional. So N, V on N is the constant value. What do you have to show there is combine them? I'm using a bit of the combined gas law. So from the combined gas law, the Boyle, Charles, and Gay-Lussac, what you get is, you get that as Vp on T is a constant value. This is the combined gas laws. Gas law. But Sky, does combined gas law tell you the exact quantity or exact value? Or would that be more qualitative? So this is more qualitative. So scientists are wondering like how can I make them to the quantitative, so to find the actual value. And this is the reason why they introduced the R, which is the gas constant. That's 8.314. Let's write down units given on your formula sheet. 314 joules per mole and Kelvin to produce what? PV equals to nRT for the final. But after we
J mole.
J per mole, mole per -1 Kelvin. So by introducing the gas constant, now from the combined gas, which was a qualitative method, we can now find the quantitative, which is called ideal gas law. So you have to remember the difference here. This is qualitative, means yes, we can compare in the two different situations. Okay, but it may not be a universal. So this is the reason why the scientists found out the gas constant, which can be used universally, like it can be applied anytime, anywhere. This is a very common question you can get in the school exam. So I recommend you to make your sample answer. This is what I'm going to mark harsh next time when you take a retest. Yep. So I just make a summary of this, but it's a 6 marker, and I'm giving you this much space or even more, means that you need to write quite a lot. So guys, try to make it a good paragraphs. Don't write it like, don't connect them. You can just state the individual laws first. At least that's giving you like a 3 to 4 marks, 3 marks out of 6, and then try to combine them. This is about how you're going to combine those gas laws, individual gas laws, to develop into the ideal gas law. Questions? You good? Good? John, you good?
Yes, yes.
Okay. Brendan?
Yep.
Good. 32. Nitroglycerin C3H5NO3 liquid is used as an explosive and undergoes the following decomposition reaction. This is basically known as a dynamite. That's what makes a dynamite. Okay, calculate the molar mass. Okay, could you guys highlight this? It's a molar mass of 1 mole of the nitrogen glycerine. 1 mole means that even though the question is asking you find the molar mass, is we need to find for 1 mole, your unit should be in the grams. That's for the mole. Okay, and did you guys get 220 something?
Yeah.
22.
7.1.
Yeah, 227.1, and you find the, but the unit is gram, not in the gram per mole, because it's given as in the mole. Tricky.
So if you don't do units,
You get it wrong.
just don't get a mark, right? No matter how much work you have, no matter if you get it right.
That's what I did.
Yeah, me too.
Same. Yeah, same over here. I think John got it right.
Oh wait, what?
I put grams on.
Yeah, you put the grams and you got it right, yeah?
This is the only question that I.
This is the only question he put together. Yeah, correct. I mean, not the only question, but this is the only question you got to correct by himself.
This is the only question.
Yeah.
Easiest question.
So I was like, "Ooh, John, yes, let's go." And then, what happens to BNC?
Uh-oh.
Yeah, exactly. Dude, BNC is much easy. It's actually easier than question A. All right, how many moles of the gas would be produced by decompose 2 moles of the nitroglycerin? So, molar ratio of this is 4 to 6 to 10 to 12 to 0. Question's asking you about moles of gas. Means that, well, how many gas we have? We have gas, N2, H2 is gas, CO2 is gas, O2 is gas. So we need to consider all the gases. So 4 moles of the nitroglycerin, the reactant, they will be adding 6 plus 10 plus 12 plus 1, which is making 29 of gas produced. That means 2 moles of the reactant, half of that. That's 14.545 moles will be produced. Easy? Trick is, yes, this is the reason why I emphasize the states so a lot. If you get it wrong with your states, you won't get the right answer. I mean, this is given, they're giving you the formula here. So it's good. Say what volume of gas will be released by decomposition of the 4 moles of the nitroglycerin at 25 degrees Celsius. The question is kind of embedded that they are using the standard lab condition, 25 degrees Celsius. So for the 4 moles, as we did produce 29 moles, so as V is equals to N times Vm, and Vm at the STP is 24.79. So that is 29 times 24.79. You should have that 718.9 liter.
Isn't it?
Something wrong?
Oh, what? I got it wrong, but you said I got it right.
Don't tell him that.
1 mark. It's fine.
Yeah,
We'll
okay.
make it better.
Wait, where did you get 24.79 from?
That's what the molar volume at the STP.
Oh.
Oh, sorry, SLC.
Oh.
Lucky you. Why do I give you a mark for that? Okay. All right, 33. Solid calcium metal reacts with the excess hydrochloric acid to produce salt and gas. I don't know why many of you wrote that calcium chloride as CaCl. I don't know why. Yeah. Calcium solid plus HCl state aqueous produce CaCl2 aqueous or solid, doesn't matter, I left in the aqueous, plus the hydrogen and the gas, which is the hydrogen gas, H2. I don't really consider that this is a hard question. I mean it. And there'll be 2 HCl to balance that. That's A, 2 marks. Why is it 2? I'm counting for the balance equation, also counting for the states. I told you that your states will be counted from now on. If you get it wrong with the states, sorry, I can't help it. You can't get a mark for that. If you get it wrong or 2 states wrong, CaCl2 must be. Yep. Brandon, you good?
Yep.
B. Calculate the volume of the gas that is formed at the room temperature and the pressure when the 3 grams of calcium is dissolved in the excess hydrochloric acid. So what we have is mass of the calcium is given at 3.0 grams. Number of mole of the calcium is therefore m of the molar mass. 3 divided by the molar mass is 40.08 of the calcium. So you should have the 0.075 mole. Okay, so from the equations, 1 mole of the calcium will produce 1 mole of the H2. So NCA will be equals to NH2 as the reaction. Yeah, I'm writing this again. ratio of the Ca2H2 is 1:1. That means that NH2 is therefore 0.075 mole 2. Now, trying to find the volume of H2, the conditions given as what? This is room temperature here again, which is standard lab condition at 25 degrees Celsius. Again, V is equals to 0.075 times 24.79 at the SLC. So that will be approximately 1.9 liter into a specific value.
So I got the correct answer, but you marked me wrong.
Yeah, because you just write the 1.9 liter in your answer.
Oh, I showed all the things and I put in the calculator.
Oh, okay. Yeah, I think you should get 2 out of 2. Yep, I fix it. Yeah. C. In a second experiment involving an unknown mass of calcium, 0.75 liter of the gas was produced at the room temperature and the pressure. Okay, calculate the concentration of the 425. Guys, this is what you will get in the school exam commonly. This is what you will get. If you learn up to the gas law, and if you're getting the questions, you half of the question up to gas laws, this is what you will get. So, moles of the H2 from the volume, so N of the H2, we go the opposite. We go in like the reverse way, the opposite way. Is equals to volume divided by the 24.79. That was given as volume was given as how much? 0.75 divided by 24.79. Then you should get the number of mole for the H2 is 0.032 moles. Again, use the reaction ratio for as the reaction ratio of H2 HCl this time, as we need to find the HCl is 1:2, and HCl must be twice of the NH2, that is times 2 of that, so that will be 0.06050 mole. Got up to here?
Yep.
Good. Number of moles is given. Now, volume of the gas, hydrochloric gas is 425 milliliter. So concentration of HCl is C is equals to N over V. That is 0.06050 divided by the volume, which is 425 milliliter, so 0.425 liter. Then you should get 0.1423, which is in how many sigfigs do we have? 2 sigfigs. So leave that in 2 sigfigs like this.
Oh, what?
Oh, what?
Is that the answer?
That's the answer.
But it says calculate the concentration.
Yeah,
Have it.
yeah.
14%. That's the concentration.
Why did you get the where did you get the 14%? When did I tell you to find the percentage, Sky? When did we ever ask you to find the percentage in what? This is why you got the right answer, but you put the wrong information there. Your marks get deducted. I mean, because I'm a harsh person, yes, I deduct the mark. Some generous chemistry teacher will give you full mark for that, as you got the right answer, right procedure. But be aware.
So,
Yeah.
me though, I use like a whole different technique, but I still got it. That's the thing I'm testing. Because I used the.
No, you got the different value, Sean.
What do you mean C?
Your value was 0.0156 gram per mole. Gram per mole.
Oh no, for B, sorry.
Yeah, so that's why I'm giving you extra 2 marks for the B.
Yeah, but I did it a whole different way.
That's okay. That's okay. As long as you use the some rational, logical way. I mean, I can see that you try to use the ideal gas law there,
Yeah.
and you find the number of moles of the calcium,
Yeah.
and then substitute that into that. Yeah,
Yeah.
that's okay. But try to use the molar volume if you know any molar volume value. All right, last question, 34. A student investigating the gas laws obtained in the following data for an investigation of the relationship between the volume and temperature. So this is about volume and temperature. Brandon, what are the 4 factors of the gases? We have a volume and temperature. What are the next 2?
Pressure and moles.
Pressure and mole. So if you keep the testing for these 2, we must make these 2 be constant as a control variable. So the answer is you must keep the pressure and the number of moles to be constant. Next one, graph. Okay, when you have, Brendan, when you have these kind of data here, which is your independent, which is your dependent variable?
Is
From temperature and the volume, which is independent. Temperature is independent, and generally we put the independent variables on your x-axis. I don't know why. Yep. So I mean that's kind of general rules. There are some exceptions sometimes. Try to use the independent variable on the y, but that's kind of making you better answer too. When you're writing your answer for the graph, John and Jongmin, temperature temp is a shortened term. It must be the full word, temperature. Okay? And the unit must be written down too. Unit of temperature is degrees Celsius. You must write the unit.
It's kind of sad.
I did that.
Yeah, I know.
Oh.
What marks you get?
I lost the mark because of the little.
You lost the mark. Okay, Jongmin lost the mark. I show you what he have done. Jongmin lost the mark because he showed like this. This.
Look, I'm not hitting the tiniest bit. It's the tiniest bit right there. And you have to cycle it.
Wait,
Put an X next to it.
for?
It's not even that big. It's like half a centimeter. Okay.
John, what is the unit of the volume?
Damn.
I have nothing to say. This is something probably you have done from what? Year 8, year 9, year 10. So a graphing question, you will get it till you finish your HSC. Oh, sorry, you will get it. And physics, if you do physics, yeah. It's your destiny. You will get it. And you will get a second-hand data too for your exam coming, Brandon, next Tuesday. Skills test. That's what the skills test is about.
You do physics as well?
Yep.
Yeah. I hate it.
Well,
Oh, that's a strong word. No offense.
no offense. Okay. All right. So graphing question, temperature and the volume scales, plot, and this is how we get the 4. Very straightforward. Brandon, this is really straightforward. 4 means that there are 4 factors: labeling, legends, okay, plotting, and they make sure in the straight line using the ruler. No branches, no tip, no.
It was a mistake.
I don't care. I don't care.
I'm like, it's like half a centimeter.
I don't
And
care.
you put a bit like.
I don't care. Again, I don't care whether you made that as a mistake or like, you put something. I don't care. So, Jongmin, you probably learned from your mistake this time, okay? Don't ever check your answer. If you think there's something wrong with your graph, fix it.
Right.
You had 2 hours for the exam.
It's my fault.
And there are so much blanks in your answers. I don't know why. Last one. Which law has this student been investigating? All right. Very good question. Charles' law, 1 mark. And if you state that Charles' law is directly proportional of the temperature and the temperature and the volume, get another mark too. You must relate that to your graph, showing that the graph is showing the good positive gradient value. Awesome answer, Sky, by the way. positive gradient value, which means show what? It shows the direct proportional relationship. Don't just write it, hey, they have some relationship. I feel like this.
As shown in the graph.
Yes, someone wrote it like there are some relationship between the T and B. I'm not asking you that. I'm asking you what the relationship is.
Who wrote that?
I don't know. I forgot. Okay.
Our class?
Only me.
Was that him? Wait. Go, what did you write?
No, it wasn't you, John.
Oh.
You're on the good track, but you didn't relate that to the graph again.
So what am I supposed to say to get the 1 extra mark?
One extra mark, you must relate that to the shape of the
I'll just
graph.
say from the graph above.
From the graph above, what can you tell?
That it's just a straight line gradient. You know.
So write it down. As the graph has the positive gradient straight line, showing that direct proportional relationship between what? The temperature and the volume, it must be for the Charles' law.
Okay.
Okay?
Yeah.
That's it.
Okay.
Home time?